Hello, everyone, and welcome to a very fun CB session today on the unofficial AWS News Feed. Luke, forgive me because I might butcher your name pronunciation. So I just want to say we have today joined to us by AWS Serverless Hero and former AWS Builder of the Year. So I learned Luc van Donkersgoed joining us from the Netherlands. And Luke, honestly, and I've communicated this internally as well. I have nothing to support this notion, so I am not providing any information. But if you guys saw the update yesterday on the product life cycle webpage, I truly believe that Luke's coverage of service updates, service depreciations, and just service life cycles had something to do with that. Like I sometimes learn about things that are happening at AWS because of Luke's updates. So like just in case you guys think that like, we have this knowledge as AWS employees long in advance and we're just like holding it in and not communicating with each other. We often find out these things in real time as well. And it's because of the help of people like Luke where I learn a lot of these things. So, quick announcements before we get started. First off, this is being recorded. The recording I should have it available by the end of my day today, but if not, it'll be available tomorrow at the latest. Also, Q&A. We're going to hold off Q&A to the end just because Luke has a lot of information that he wants to present on. And so we want to make sure that he has the right flow to do that and that we don't want to interrupt that because it's a lot of information to get through. We want to make sure that we are clearly communicating all of that to you. So if you have any questions, two ways that you can be able to ask them. Primarily, enter them in the message chat here. That would probably be the easiest. So feel free to ask your questions. I'll be paying attention to them and cataloging them as we get ready for Q&A. I will begin asking them. Also, if you really, really want to come off mute, probably towards the closer to the end of the presentation, raise your hand. So I'm raising my hand, I'm lowering my hand. So if you raise your hand, that's going to indicate that you're going to want to come off mute and ask your question live. So those are your two options there. With that all said, thank you very much, Luke. The floor is yours.
Awesome. Well, thanks, Corey. And thanks for having me. Thanks, Community Builders, for having me. I'm really looking forward to presenting this story about the AWS Newsfeed to you. So let's dive in. The unofficial AWS Newsfeed. First, let me quickly introduce myself. I'm Luc van Donkersgoed. You said it pretty good, Corey, for an American. I'm an AWS serverless hero. And also a principal engineer at PostNL. And you might know me from some blog posts and conferences, blog posts that I write, conferences where I talk around mostly Europe. And indeed, I'm very active on social media, so might have seen me there as well. But we're not here to talk about me. We're here to talk about the AWS newsfeed. So let's start at the beginning and just ask ourselves, what is the AWS newsfeed? Well, it's a website, obviously, and you can find it at awsnews.com. But what is it really? Well, the way I look at it, it's a data aggregator and also a data management platform, albeit a very simple one, but that's in the core what it is. So what it does is it checks the AWS blogs and AWS What's New feed every minute and then aggregates the results and presents them in a single place. But the main difference between my official What's New AWS newsfeed and the, sorry, mixing them up now, my unofficial AWS newsfeed and the official sources is that at my website, you can mark items as read and you can manage the data and personalize it really in a way that works for you. So let's dive into these features a little bit deeper. I guess the first and probably still the most important feature of the AWS newsfeed is the ability to mark an article as read. So you can just check this box and then the article is marked as read. And if you're anything like me, if you're really enthusiastic about AWS and you want to keep up with everything that's happening and what's being released, um, you know that AWS releases a lot of news, a lot of news announcements and blog posts. And actually keeping track is quite difficult. So just being able to mark items as read, just knowing, okay, I've seen this already and I haven't seen that yet, I still need to dive into that, uh, can help you a lot. But if you're just marking items as read, uh, you might get into the point where you did actually read something, but you might want to get back to it later, right? And then you can mark it as unread, but that's actually not really what it is. So the next option is to bookmark items. And this is just the simplest label that you can have. You just add the bookmark, and then later you can select your bookmarks here on the right, and then it will only show you those articles that you bookmarked. But then again, of course, time goes by. You bookmark a lot of items, and in the end, you have 500 items that are bookmarked. And then again, it is still difficult to find the one thing that you're looking for. Um, so if you want a little bit more granularity, you go to the next level, which is ratings. And ratings is really just a 1 to 5 star rating, which again lets you categorize, but also filter in a little bit more detail. So you can, for example, say, I want to see all the articles that I gave 3 to 5 stars and not the 1 and 2 stars, right? Gives you a little bit more flexibility. But the thing is, with ratings, there's some sort of value attached to it, right? If you give something 5 stars, you might, for yourself, say, hey, uh, apparently I really like this. And that's not always the kind of categorization that you want, right? You don't want to say whether you like it or not. You just want to have categories so that you can easily find it back later. So that's the last granularity. If you really want to organize your news and blogs in the most granular way, you can create tags and just attach those tags, any that you created, on those articles. And they're private, so only you can see them. And well, we talked about deprecations just in the beginning. For example, I have the tag deprecation. I can mark that to my or attach that to my articles, and then just a single click. And I can find all the articles that are about a deprecation in the feed. So this is really how you can organize your data, and that's why I call it a data management tool. Um, at the top, you can also see a search bar. It currently says Lambda, and this will simply search for that term in all the titles. But of course, Lambda is a very good term. If you search for that, you will find all the articles about Lambda. Um, and in this case, I'm actually combining two filters. So I have the Lambda search at the top, but I'm also searching for the pre-event top post category, and then I get all the top posts with the word Lambda in it. So this is really how you can find and manage that data. One very important one is filtering on unread items. If you turn this on, it will only show you the items that you haven't seen yet. And then we have here the function to mark everything as read, so that you just start with a clean slate and start over. So yeah, this is the AWS newsfeed at its core. There's a lot more to it, and we'll get to that. But this is really the basic, the basis of the application. So I think one of the questions that I get the most about the AWS newsfeed is, why did you build it? How did it start? So let's dive a little bit into the origin story. And to do that, we have to go back to reInvent. Not physically, not today, but at least in our minds. And I think it might be familiar to a lot of you that if you're really active in the AWS community and maybe you professionally are also involved with AWS at work, and you're a community builder, of course, then people kind of expect that you're able to give them updates and insights about AWS as well. and especially around reInvent, right? We have the recaps after every reInvent, where you have to give your summaries, what's new, what's important, what to pay attention to. And this is the same for me, right? And so I've been to reInvent a few times. I've also watched them virtually from home a few times. And what I always did every reInvent is just create an Excel sheet in which I tracked and copied and pasted every single release during reInvent. And there are hundreds of them. So I copied the title. I did my own categorization. This is from the 2020 year. I added the date. I added a link to the What's New page and the blog page as well, if there was one. Now, those of you who regularly work with Excel, you know that pasting links in Excel is terrible, formatting is terrible, so this is just a headache, right? But I went through my backups and I actually found that I built these Excel sheets 3 years, in 2020, 21, and 22. Yeah. So then reInvent 23 came around. This is about a year and a half ago. And I was going to Vegas, luckily. I was looking forward to it. And in about a week before, the weekend before I would fly out, I started to prepare. So I started creating my Excel sheet for that year. And as I was doing it, I was just annoyed. It's like, okay, this is just crap. I just don't like doing this for the fourth year in a row. And then I kept on thinking and I thought, hey, I'm an AWS hero. I should be able to build some sort of solution for this, right? I should be able to do that. Um, so that's what I did. A week before reInvent, I started building, and I built this. This is the very first version. You can already see some familiar elements here. You have the search bar at the top. This is on mobile. It didn't even have a domain name yet. It was awsnews.l15d.com, which is the I don't know what the name is, the numeric version of my name, which I use for pet projects and so on. It doesn't have a design, so to say, just a table. But I already had my data, and now copy pasting is easier, and I get an overview. And then quick addition to it is if I didn't read it, I made the text bold so I could see what I already read and didn't read. And then when you click it, it automatically marked it as read, and that's about it. So I released this. I started building this on a Friday. I released it on the Monday after, so I built it in the weekend. Then I flew to reInvent and used it during the keynotes, during my session, my time there to find what's new and keep track. And I also shared a little bit about that on social media. And actually, there were quite a lot of people who liked it and started using it. So in that first week, I already got hundreds of users. So that's pretty cool. And then I kept on building it afterwards. So this is a screenshot from January 24. So this is a month later. And you can already see that there's a little bit more of a design. You can see some of the features that are being added. These were just the high priority things that, well, just made a lot of sense to add there. So this is how it started. But what I found interesting in that process is I started building it, and I started building it just to solve a problem that I had, right? I was annoyed with my Excel sheets. I wanted to build a solution. I think maybe that's the best drive you can have to build something, is just being frustrated by what's not out there. But what I also thought is, if I'm building this for me, I should always immediately make it available to the community as well, because I'm not going to be the only one with this problem, and I'm going to have to put this online and add some security anyway. So how much more effort would it be to just add a user pool and allow other people to join in as well? So immediately from day one, I started building this with the community in mind as well. And then as it actually took off, Now I have thousands of users on the website. So um, now I'm constantly thinking, okay, what's the biggest problem that people have? What feature can I build? How can I help the community the best? But still, I think I'm personally the number one user of my website. Um, so yeah, that's how it started. Now we already talked about the core features, but there's more secondary features to it as well, and there's a few that I really want to highlight. And the first is summaries. So some of these blog posts that AWS brings out are really long, and sometimes you just don't know whether you want to read it, whether it's worth reading the entire thing. So I found that a summary, and this is of course where foundational models can help a lot, uh, would really add value. So I just generate this one paragraph or two paragraph of HTML, and this is what you can find on my website. I don't copy the text of the original article because that's what you can read on the AWS News blogs themselves, but the summary is unique to my website. Then the second feature is related articles. So here at the top, you can see the news article introducing AWS Glue 5.0. And what AWS often does is you have a news release, an announcement, and a blog post that's a deep dive. But there's no relationship between those two in AWS, right? You can't jump from one to the other. And that's something that I actually often do, especially during reInvent. So using embeddings and storing them as vectors in the database, I can actually find which articles are most similar to other articles. And because a news article and a blog post about the same release will often, of course, look a lot alike, you will find that this blog post is generally the most related article and then ends up at the top of that list. And that makes it really easy to switch between these articles, but also find other articles that are also related to this news, which I think is really valuable. And then the third one is email digest. So every day, every week, and every month, I send out an email with a summary of what happened, what's new and most popular in the past period. So in the past day, past week, and past month. And this allows you to really receive these emails in your inbox. And you don't even have to go to the website anymore. You just get a digest of the 10 most important articles of the day. And I think this is actually what people might like the most about my website at this time. So this is what I built. This is why I built it as well. So I think next it's interesting to look into how I built this. What technologies did I use? What kind of approach did I take? But before we really go deep into the technology, I want to talk about guiding principles for a little while, because you have to be aware that I built this by myself, and I built this as a kind of hobby project. It's grown to more than a hobby project, but it's still a side gig, right? Um, and if you're building something by yourself, you're and as a side gig, there's quite a few constraints that you have to live with. Um, and I find it very important to think about those constraints and set out some guiding principles that help me uh, make decisions, like how do I do things to keep it maintainable and keep it approachable. So the first guiding principle is that it needs to be cost effective, because I'm paying for this by myself. I'm hosting it myself on AWS, and it's my credit card that's linked to that account. Of course, I do have AWS credits, but if you have thousands of users, it's actually quite easy to run through those AWS credits. So you have to keep this cost effectiveness in mind at all times. Um, the next one is that it needs to be scalable. Because sometimes in the weekends, I hardly have any users. On Sundays, luckily, most people are not looking at the AWS news. And at some times, especially of course during reInvent, I have tens of thousands of users, and it needs to work in both these situations and at all times. So it needs to be scalable. And this is one that's really interesting to me. I'm building this as a side project. I'm building this for the community, but I'm also definitely building this as a platform for experimentation, right? If I want to try something new, it is super valuable to have a platform with actual users, actual data, and a production environment where you can experiment with new technologies. So, for example, last week, I started experimenting with the S3 directory buckets, the Express One Zone storage class. Um, and um, I have a platform here where I can have an actual use case, can build actual value using these technologies. So I can get familiar with these technologies. Um, but yeah, the learning context is just so much more valuable. So keeping this platform, this website, and building it out also as a platform for experimentation is super important to me. And then the last one is that the guiding principle for me is also that it has to be fun to build. Because again, this is a side project. I'm not getting paid for this. We'll talk about money in a little while. Um, but I'm doing this for me. And as soon as I'm building this and it feels like a chore, it feels like it's not fun, it feels like work, then what am I really doing it for? So making sure that it continues to be fun is extremely important to me as well. And you can explore this principle of it being fun to build a little bit deeper as well. So what does it actually mean to use fun to build as an architectural principle? Well, it means that it has to be easy to understand, right? If I look at my code or look at my infrastructure and I have no clue what's going on, and I have to investigate anytime I need to want to build something new, that's not fun, right? Uh, Same goes for the evolvability. It needs to be easy to evolve. If I want to add a new feature or remove an old feature, uh, that shouldn't be difficult or a lot of work. It should be easy so that it remains fun. It should also be easy to pick up after a hiatus. So sometimes I don't work on the project for weeks and sometimes even months. And then picking it back up should be easy as well. I shouldn't have to read through all of my code and all of my infrastructure to find out how things worked again. It should simply be easy. So, in other words, what being fun to build should be is actually the same as minimizing cognitive load. It's just more expensive words, right? Uh, if you minimize the cognitive load, the amount of thinking that you have to do to work on your project, you're almost automatically making it fun. Now, one other aspect that I do want to touch upon is maintaining quality. Because there's this kind of conflict where you're building your own tool as a side job, and then you're just doing it in your evenings and weekends, and you're just having fun. But at the same time, you have thousands of users. And at some point, they start to depend on your platform working all the time and the emails going out on time and so on. So, how do you maintain quality without spending every weekend and every hour on it? Well, there's again, the basis is having strict principles, but you have to apply those strict principles to a few levels. The first is systems architecture. So I have a very clear idea of what the systems architecture looks like, and I stick to those principles. The same applies to software architecture. I have a very clear idea of how my code should be structured, and again, I stick to those principles because that's how I maintain quality. Of course, there's testing, so I have hundreds of unit tests running on my application and at least dozens, maybe by now 100 of end-to-end tests running on live deployed code as well. That really guarantees that whatever I do in my systems, it doesn't break any of the existing functionality. I have a CI/CD pipeline which automates everything, so I can't bypass any steps. And in the CI/CD pipeline, I also guarantee linting, formatting, and type checking, which really are fundamental principles to maintain quality as well. So by applying all these principles, I'm actually making it easy for myself to maintain quality in this side gig. So that all being said, now let's take a look at what the systems architecture actually looks like. And this is it. This is my systems architecture. I have a front end and a back end and a core application. Well, of course, this is the highest level of the systems architecture. We can also dive a little bit deeper. So you can apply these three layers, front end, back end, and core application, and spread them out a little bit. And then you see these layers. So you can see a front end, and then the back end is first the edge layer, then control flow layer. Then we have our core application, and we have persistence messaging and then the foundations layers. Now, if we dive another level deeper, this is what it looks like more or less in practice. So you can plot these layers that we just discussed on these components. At the top, we have the front-end layer. That is a Fargate container running a Next.js server. There's a lot to be said about the front end, but that's not the focus for today. So if you want to talk about that, let's do so at another time. Then we have the edge layer, which is CloudFront and Web Application Firewall. And we have the control flow, which is things like scheduler, Lambda functions, state machines, and so on. Then we have the core business logic, which is a Python application, which communicates with the persistence layer, which is DynamoDB, Aurora Serverless, Identity Access Management, Cognito, and so on, and S3. And then we have the messaging layer, which is EventBridge and SQS. So this is the high-level systems architecture, and pretty much anything I can do, anything I do within the platform, I can plot on this systems architecture. And my CDK project for my infrastructure as code is also organized along these lines. So that's really how I maintain that structure. Now let's see how these systems work in practice. And I have three examples of how data flows through the system, just to give you a bit of a feeling. So the first one is fetching news. So in the control layer, the control flow layer, we have a scheduler which fetches the news every minute. That triggers a Lambda function, and the Lambda function triggers the business logic in the Python application. And the business logic validates that the article does not exist in the database, and then stores the article in the database. But then it continues in a event-driven manner and sends out an event that's called the new article stored event, because we need to do stuff with this article that was just stored. That is picked up by a Lambda function or maybe a state machine, and that state machine then triggers the core application again. Now it runs another function, which is the business logic to enrich an article with a summary. Stores the summary in S3, but even then it's still not done. So it sends out another event, says, hey, the summary has been stored. Because again, other processes depend on this. So there's another Lambda function that responds to this and calls the core application to post this summary onto Blue Sky, onto social media, so that other people can actually discover this this article there as well. So that's really how the control flow goes for that use case. Another one, which is mark all as read. This is a user-facing action. So in this case, the user on the front end marks all articles as read. That triggers an API backend through the CloudFront layer. Again, that triggers the Python application, and in this case, it sets the mark all as read date in the database. And then emits the mark all as read command. So again, this is an asynchronous process, because now we can return the success response immediately to the user. And then in the background already start doing the cleanup that has to happen when you're doing a mark all as read as well, but where the user doesn't have to wait for. So that triggers another business logic which updates all the user article data, updates that data in the database, and then the process is done. And one last example, if a user gets a non-existing summary, so this is how errors are being handled. Again, this is a user-facing interaction, so they get the article summary, but for some reason, this summary for this article is not yet available, so the summary is not found. Then we emit another command, which is the update summary command, and return to the user the response, sorry, the summary was not found. But the front end actually shows a message now that says, please check back in a minute. Because in the background, the update summary command is again received by our control flow layer, triggers the Python application, which enriches this article with a summary, stores that in S3, and then the next time the user tries to fetch that summary, it will be there. So that's how error handling works. Now, what you have probably noticed in all of this is that everything goes through that central Python application. That's technically the beating heart of this entire system. So let's take a look at what that application actually looks like. And let's talk a little bit about software architecture. If we zoom into the previous diagram a little bit more, you can really see that this central application is responsible for many things, right? From processing user requests, summarizing articles, posting to Blue Sky, sending out emails, marking things as read. Just the list goes on. Everything is within this single application. So you could say, you would be right in saying that this is a monolith. But monoliths have a bit of a bad reputation for maintainability. And I said in the beginning that it should be easy to evolve. It should be fun to build. So how does that rhyme with a monolith? Well, to answer that question, let's first look into a bit of the alternatives, right? This is a classic architecture. It's probably called nanoservices, where every Lambda function might have its own little piece of code, right? And so only responsible for that functionality. So the code for each of these Lambda functions is naturally separated, which might make it more easy to maintain. But often you'll find that some of these services need to do the same thing. So for example, we have a database with articles, and the article service to retrieve those articles and the email sender might both need access to that database of articles. Now, to do so, you could implement the same code in both places, but then you have code duplication, which also means that if you want to change that code, you have to do it in two places. And then you have to make sure that you do it at the same time as well. Now, to solve that problem, one solution is to add a code library, which has all the business logic for interacting with articles. But now you have to make sure that these Lambda functions use the same dependencies. You probably need a private repository for your artifacts. You have to make sure that your versions are up to date and so on. So that adds a lot of overhead there as well. Another alternative is that the email sender does not directly talk to the database, but calls the article service itself, so that all the responsibilities lie in the same place. But now this internal system is going to have to use an API, maybe have some authorization on it, call that Lambda function. Your chain becomes more complex, and there's more components that can fill. So this adds complexity to the system as well. So instead, I chose to just put everything in one application, one big monolith, so that all the code is always up to date across all systems at all time. But this, of course, does mean that all your code is in one place. So you get questions about maintainability and the how you can make sure that if you make one change at one end, it doesn't affect the other end. And that's really where software architecture comes into play. And the way I use software architecture to solve this problem is by using the principle of onion architecture. Now we're going to dive into onion architecture on the next few slides. The thing is, onion architecture uh, is a topic which I could easily fill another hour or two with. Um, it's just, yeah, software architecture, you can't really do that in 5 minutes. So if you're not familiar with onion architecture, this next section might be a little bit dense. Don't try to understand everything in that case. Just try to see how these principles of applying software architecture are helping me to structure and maintain my code. And if you want to learn more, then you can reach out. I can give you some resources, or you can try to find your own resources on the internet because there's quite a lot out there. So that being said, let's take a look at onion architecture. This is really the diagram that I always use, and it has three main components. The inner circle, that's the application services, domain services, and domain model, the inner three. Those are your core applications. Those really define your application. That's component one. Then component two is the outer circle around that, the user interfaces, infrastructure, and tests. And those don't have anything to do with your core application, but you still need them to make sure that your application works in a production environment. And the third component is the orange arrow, the dependency direction, which says that systems, any component in any of these layers can only depend on deeper layers or the same layer. Um, so we'll get into what that means in a second. But this is the diagram that I use. Now, let's take a little bit of a deeper look at each of these components, starting with the domain model. Now, this is the core of the onion. So this means that whatever you put in here can't depend on anything else because the dependency direction is inward. There is nothing more inward than the domain model. So these entities really live in isolation. They don't know anything about about the world outside of their own entities. So it should be things like your business objects, so your articles, your tags, your article user data, whatever entities you use to describe your business. And there are some rules. The first I already mentioned, it should have no dependencies on the rest of the software architecture. You really use this to store data objects, so to define your data. And you can have some local data operations that stay within the entity, like updating counts and so on, within that entity. Then moving on to the second layer, the domain services. This is where you store business logic. So I have some examples here: convert HTML to Markdown, generate email from template, calculate articles with tags. So you can see there's some business processes going on here. And there's also some rules. And the first one is the most important one. The services in the domain service layer should have no side effects. So what that means is you give it one input and you expect one output, and there's no other systems being affected by the fact that you just did that. So there's no data being stored, there's no events being emitted, there's no database being updated, there's no interaction with external services at all. So there's no side effects. It lives in isolation. What's also important here is that there's no orchestration. So that kind of goes hand in hand. If you just have an input and an output and no side effects, then you can't orchestrate any other services outside of yourself either. And you have this inward dependency, so you can use other domain services, and you can use the entities in the domain model, but that's it, right? That's all the dependencies that you can have. Then moving on to the third layer, the application services, and this is where the opposite happens because this is only orchestration. This is where you do things like get all articles, mark all as read, send digest batch. And this layer is responsible for orchestrating all the external services and internal services and domain services and domain models to make these use cases happen. So the rules here are, in this layer, you can only have orchestration. And if you're interacting with external services, you're not defining those external services, but you're defining ports, which is just the kind of abstract interface, like object storage service. You're saying, I want there to be an object storage service, and that's how these are the operations that I want to have on it. And those are ports. We'll get into this in a second. And then the third rule is that, of course, because of the inward dependency, it can call domain services, entities, and these ports. So if the application services define the ports, then you have to have adapters somewhere as well. And this is in the outer layer, the infrastructure layer. And this is where you have your adapter. So your port lives in the application service, your adapter lives in the infrastructure service. And this is where you'd really do the implementation of your port. So if you have an object storage service, you have an implementation, which is the S3 service. But your core application, the blue circle and everything in between, know nothing about the fact that this object storage is actually handled by S3. You keep that in isolation. So let's take a look at what this model looks like in practice. I have two examples, and the first one is an HTTP request. So a user does a get articles. Now your core application doesn't know anything about HTTP or about requests or anything, so that's handled by the user interface. And the user interface then calls the use case, get articles use case. And this is then the orchestration that does everything that needs to happen for it. It says, I need an article repository to call get articles, and this is implemented in the infrastructure layer with an RDS, article repository, which actually handles that call. Then it returns a list of article models. These are the entities. Those are returned to the user interfaces, and they convert that to an article's response in JSON and HTML and so on. And this is how you keep that isolation. Second example is an event. So there's an event coming in through EventBridge. It's called new article found, and it calls the enrich article use case. This also has a port which says there has to be a content service to get page content, but doesn't define how that is implemented. But the infrastructure has an HTML content service which actually does it. Then we have a domain service, markdown service, convert HTML to markdown. So this one lives in isolation, has no side effects. Calls another port for an LLM service to summarize text, which is implemented in the Bedrock service. An object storage service, which is implemented as an S3 service, and an event bus service, which is implemented as an event bridge service to emit another event. And this is really how the code is structured and how you define responsibilities. Now, as I said, that was a whirlwind, right? That was a lot of information in not so much time. And if you're not familiar with Onion architecture, you're probably maybe got 20% of it. And that's fine. What I really wanted to show here is that this is how I apply modularity and strict software principles in my project, which makes the system maintainable and predictable. And by doing that, this modularity for me keeps the building software fun, because you know where to expect things, and things are always only in one place in the layer where it should be. But as you've noticed, modularity is also hard cognitive work, right? Your brain is wrestling with these concepts, like what goes where. We have ports and adapters, and we have application layers and domain services and so on. How does this work? And this is really a lot of thinking involved in getting that done. And I think it's really a fun part of the puzzle. But what I've also found is that by doing this, AI doesn't really help. It's really difficult to explain to an AI, this is my software architecture. These are the principles that I apply. This is how I want it to work. AI just puts the code wherever you want it, and that actually makes it the unmaintainable uh, piece of spaghetti that we don't like, that doesn't make it fun. So what I found is the human part here is really the design, really the architecture, defining all the places where everything should go, and then within those places, AI is of course really good at filling in the code and writing the actual business logic. So that was the deep dive. Now, on a bit of a lighter note, we're going into the last section. Um, and that's learnings and numbers and a bit about money. So first, learnings. A few things that I found really interesting that I learned during this project. One is designing for cache is a skill. If you want to make things cost effectively, um, you have to do caching. But if you're applying caching, you actually also have to think about your data structures so that you can split things that you can cache and separate them from the things that you cannot cache. It was more difficult than I expected it to be when I started. Gen AI chatbots bots are hard. I started with a chatbot way early. The thing is, you can make a chatbot that works fine if people only ask it what you expect them to ask. But as soon as they start asking things that you didn't expect, then the AI chatbot generally doesn't have the data to answer it, so just make something up. And having that entire data foundation to make sure that you have a chatbot that can answer the right questions was way more difficult than I thought it would be as well. And the third learning is DynamoDB is not suitable for every workload. Of course, I started out with DynamoDB, and at some point I ended up with thousands of lines of code just to make various access patterns work on my data in DynamoDB. And at some point I thought, this is literally 2 lines of SQL code that I now solved in 1,000 lines of Python code. And because I want to keep things fun, I just threw everything out and started over with SQL and RDS and Postgres. Of course, it costs a little bit more, but the maintainability is really way higher. So I still use DynamoDB where it makes sense, but don't try to squeeze DynamoDB onto every workload. It doesn't work. Then going into some numbers. How big is the platform actually? I see I'm running a little bit late, so I'm gonna go a little bit fast here. First, cost. I said it has to be cost efficient. Currently, it costs about $120 per month to run, which is acceptable. But you can see some evolution here as well. The really big peak here is just before reInvent 2024, when I started to use LLMs to summarize everything. And you can also see in purple EC2 Other. That's because I introduced a application load balancer in the system, and that made it actually quite expensive, which had to do with the fact that I started using containers, Elastic Container Service here, which are also a bit more expensive. And here in blue, you can see relational database service being introduced. So this is where I started migrating to RDS. And now it's pretty stable at about $120 per month. Newsletter subscribers. This is from yesterday. Today, I'm over 1,600 subscribers to the newsletter, and I send out more than 17,000 emails per month. So that's quite a nice number, I think. And page views. This is over the past year. I got 103,000 people for 234 page views. And of course, a big bump here in November, December around reInvent. But currently doing more than 10K visitors per month. So that's nice. And then we talked about cost and money. And how do you actually do this? So I am monetizing the platform because I'm spending so much effort on it that I think you really can't and shouldn't do this for free. So how do I make money out of the platform? Well, I only have one way actually, which is sponsors. Um, and we have two types of sponsors. We have business sponsors and individual sponsors. And for the business sponsors, we offer the various tiers. So the gold tier is the highest tier. It costs $1,000 per month. And for $1,000 per month, you can get a placement like this. So you can get your icon, some links, and the text about your product. So in this case, it's Heroku, and this is what it looked like. The second level is silver. You're still on the front page, you're still in the email, but you don't get the text and the links, you just get your icon. This costs $500 per month. And then the third is bronze, which is for business sponsors with a smaller wallet. They can pay $250 just to support the site. And then you will be mentioned on the sponsor side, but not on the main page. So those are the three main levels. And I have a sponsor brief and PDF that I can send out with all the details so that they know what they get, what they can expect for these prices. And then we have the second type, which is individual sponsors. We have the option for a €4 per month sponsorship. Uh, and these are small amounts, of course, per person, but I hope to get a lot of people to support me because they like the website so much and it adds value to them. And of course, in large numbers, €4 per month is significant as well. So with all that said, you're wondering, okay, but how much did you actually make with this website? So let me answer it. In 2024, before tax, about €16,000. Now, unfortunately, I do have to pay tax. So after tax, this was about 10K. And this is not a bad number, right? I like the fact that last year I had 10K more in my bank account than I had the year before. But you also have to realize that I spent about 2,000 hours building this website and maintaining it. So if you, well, do the math, that translates to about €5 per hour, which is about 1/3 of what I could have made if I worked in the supermarket. So it's not going to get you rich, but uh, if you try and if you have a good network and you're motivated to talk about and share about your product and really build something that makes people happy, you can make money out of it, but not enough to live from. And that's how much I made. So big takeaway here, sponsors are super important. If I didn't have sponsors, I would not be able to do this, and the website simply wouldn't exist. So if you have a company or you as an individual would like to sponsor my site, it's super welcome and it really helps a lot. And you can visit aws.news-news.com/sponsors for it. And on that note, this was me. I'm Luc van Donkersgoed, and I'm on Blue Sky and LinkedIn if you want to reach out. Thanks, guys.
Thanks, Luke. This is really wonderful. Ton of really great stuff in here. We do have a few questions. So let me see if you answered one about pricing, so that is good. Um, since you said you built your original app in a weekend, how long did it take after that original iteration to evolve the software architecture to the onion model you described in later slides?
Um, I didn't start that way. That's definitely true. And then in February, so about 3 months after, it had evolved to a pile of shit that was unmaintainable. So in February 2024, I think I spent 5 weeks rewriting what I wrote in the 3 months before. And that's so in February and March, that's how much time I spent to rewrite. And then it got to the foundations that it currently has.
Second question. In terms of your costs incurred and that you itemized, there's a question of I'll read it literally, but inferred no web application firewall in those costs.
Uh, no, it's not significant. No. So there's a few dollars for the rule sets, but no, the way I use it, it's not a significant cost.
And then finally, from Roman, I also maintain an AWS News Feed on GitHub by transforming it to JSON format. Origin is RSS XML, and making it available for my services as a REST API. And then he cites the GitHub link, which I'll send to you afterwards. I have added all sources on main page. We'll be interesting. What sources are you using so that we can share and exchange them? Obviously, that might be a proprietary secret or something like that. But if you're willing to provide
No.
any,
So I'm gonna do this really quickly because we're all nerds. What I did was I went to the what's a new AWS site here. I opened DevTools right here. Then I refreshed the page, and then I looked through the network requests, and in here somewhere, if I filter here, there is this called search item. And in the response, you have a JSON response of all the items and all the news and everything that is in the feed. And I just did right click, copy as curl, and now I have the data.
wonderful.
So yeah, you can do it right from home.
Oh, last question. And I know you probably can't do this justice in like 1 or 2 minutes, but did you reach out to sponsors or did they approach you? What's your approach in terms of being able to get sponsorship for this?
Both. So you have a network, you have to promote it on social media and people reach out. But I also sometimes reach out to companies and that I am familiar with and where I think this might be a good platform. And sometimes we get to a deal and sometimes we don't. I've been asking AWS to sponsor me for years and they haven't yet. So Corey.
I'll see what my influence can do. And then finally, what's your advice for builders in regards to cost explosion? Like your app might not be big enough, but it could incur costs that could really kind of make this cost prohibitive. If you don't have a business plan, should you? Like, what is your advice for builders? And then we'll wrap up.
Yeah. So you have to build protections against cost explosions. Things like CloudFront and WAF and budget alerts. Um, and you have to monitor those as well. You have to set a budget for yourself. This is what I can spend. And if you see that you're going over it, you have to do work to make sure that you go back or actually change your business model. But I'm not going to turn this into a professional business, so I'm not going to look for VCs or anything. So it's mostly just controlling costs. That's the most important thing.
On that note, Luc, I want to thank you so much for your time today and for the wisdom that you shared and for the answers that you provided to these questions. Just a reminder, the recording will be made available either later today or tomorrow. Um, a reminder to visit the AWS Unofficial or whatever we want to call it, AWS News Feed. If you are interested in sponsoring for some reason or know someone that's interested in sponsoring, please feel free to do that as well and make those connections. You can connect with Luc on Blue Sky, LinkedIn, or on Slack. Luc, thank you very much. I'll give you the last word and then we'll say goodbye.
Thank you for having me. It was great fun. I hope it was valuable. I'm in the Slack, so if you have any questions, make sure to reach out.
Thank you, everyone. Have a good rest of your day. Good morning, good night, good afternoon, whoever it is. We'll see you next time. Bye bye.